2.7 graphical analysis. So we have position, time graph, straight line slope, constant velocity. So this is like so simple. It's just algebra 2, if you've taken algebra 2. So if we have a constant velocity, that means as a factor of time. Also, it's quite interesting because you can use velocity and time to explain derivatives and stuff, but honestly, I don't really care. Anyways, x. So this is, we're not dealing with a vector here. We're just explaining, it's like if this is the distance traveled here as a function of time, or in any direction, it doesn't really matter. Basically, we're seeing like at 1 second, we might be at 3. At 2 seconds, we might be at 6. So if we're assuming a constant velocity, that means we are moving at a constant rate the entire time, because the velocity is how quick we are moving. And if how quick we are moving stays the same at the entire time, our distance will stay the exact same regardless of the time. So if it's a straight line slope of position versus time, then that means we have a constant velocity. If it curves upwards, that means the position is changing way quicker as time is slightly changing. So this rate of change, if we use the slope formula, will be way smaller than this rate of change, which means that we are going a lot faster here because our position is changing while our x is getting smaller and smaller, our delta x. So back at 4 meters per second, that's the line of slope. So again, it's just a slope formula, y equals mx plus b. Here it will be 4, because we use, or here it will be 3 actually. So, wow, I deleted everything. But that means the slope is y equals 3x, meaning that we're traveling at 3 meters per second. So 3 meters per second, and since x is time, it will be x seconds. That cancels out. 3 meters times x. So how fast our x is moving, or how fast we are moving with a constant velocity. So the reason why, if it's a straight line, is because that means that our velocity is changing at the same interval each time using the slope formula. And that's kind of what a line is defined as anyways. So curved graph means acceleration is present, which means that the velocity is getting higher and higher. So if we start here and go this way, that means we're traveling way quicker up here because our position versus time, our time change, maybe it's like 0.5 seconds, but we're moving like 50 meters. That's 100 meters per second, as opposed to down here, where if it's like a change in 10 meters, we're only traveling 20 meters per second. So if it's a curved graph, that means the velocity is changing and we have an acceleration present. We don't know if it's constant acceleration though. So the slope of tangent line is instantaneous velocity, which is the derivative. I just mentioned this here. You don't have to deal with derivatives in physics. But yeah, that's the logic behind there. Velocity time graphs, straight line slope equals acceleration. So this is the same thing, except instead of using time, it's basically the derivative of x, or derivative of a position and time graph. But instead we'll use velocity versus time. So it says if we're using a straight line slope, same concept here. Our velocity is changing at a constant rate, which would be the acceleration formula, which is at plus vo. Again, simple logic here. Delta y and delta x remain the same for this entire graph here. So logic, and slope equals a. So yeah, that's it.